Okay, so indicator 15, just really quickly, I want to give you a quick rundown of the week. So typically we take a whole week on indicator 15, but I told you last week we were kind of having to squish everything in. I've kind of changed my mind a little bit because tomorrow is a little bit more challenging. And then indicator 16, I think, is one of the harder indicators we do. So rather than squish in a challenging day tomorrow into today and then do another challenging one tomorrow and then send you off for e-learning with two very hard indicators, I decided to slow down a little bit, do 15.1 today, which is fairly simple, 15.2 tomorrow, which builds on it. It's not super hard. It's just a little bit harder than today. And then for E-Day, you guys are just going to have a 15.1, 15.2 assignment. And then on Thursday, we are going to do indicator 16 together as a class. No homework. We're just going to work through 2 or 3 of the problems so that you at least get exposed to it. And then on Friday, your quiz will only be indicator 15. I'm not going to quiz you on 16. I'll give you one bonus question on the test that's indicator 16. So if you can catch what we're doing on Thursday when we do it together as a class, then you've got a chance to get bonus points on Friday. Okay, but I'm not going to give you a separate quiz on indicator 16 because it's just, I think it'd be throwing way too much at you in a week, and that's just not fair. So we're going to slow down a little bit from what we did last week, which I think is a nice breather. And we're going to break up indicator 15 into 2 days. And today we're doing 15.1, which is elimination. So I want to really quickly kind of go backwards. You don't have to take notes on this part, okay? This is just kind of refreshing our memory on what we did last week. So for SoE, which is system of equations, we've talked about 2 ways to solve them. One is graphing, and if you're specifically told to graph them, then you solve using graphing, and where the 2 lines, where you can visually see the 2 lines cross, that XY coordinate is your answer or your solution. The other way, if you're not given a graph, you cannot solve them graphically because there's no way to be accurate. So the other way we learned last week was called substitution. And substitution is really nice when one of your variables is already by itself. So, if it wasn't, you had to kind of do a little bit of algebra to get it by itself. But so for the example that's on the screen right now, y equals 2x, and then the other equation is y equals 3x plus 2. In substitution, you take what y equals from one equation, that's your clue, and then you find the y in the other equation, and then you substitute the 2x in where there was a y. And basically what that does, that little line there that has a star next to it, that rewrites your equation, everything in terms of x. Because with 2 unknowns, you can't solve an equation, right? So we kind of have to finagle it or force it to just have one unknown. And that's why we use substitution. We substitute what we know about y using an x in for the y in the other equation, and now 2x equals 3x plus 2, we can solve for x. We can get x by itself. We can find out what x equals, then we can plug that into either one of those equations and get what y equals, and we can get the point where they cross, and that's the solution, right? The one point where they cross. And if you were to graph these 2 equations, the point that you would visually see where they cross should match the point that you got when you did it algebraically. Okay, those are the 2 that we've used so far. Today, we're going to learn a 3rd way to solve a system of equations, and it's elimination. And it's kind of the same idea as far as we had to use substitution to write everything in terms of x or everything in terms of y so that we had just one variable to solve. Elimination is the same idea, okay, but we do it in a different way. So with elimination, just like the name of it is elimination. We are going to use elimination to get rid of one of the variables, leaving only the other one behind so that we can solve for it. So the way you do it is, first of all, they both have to be in standard form. And if you think way back to when we started learning about linear equations, standard form is ax plus by equals c. And here, right, you've got 2x minus 10y equals negative 28. That's in standard form. The x and the y are on the left. The whole number's on the right. If they're both in standard form, you stack them on top of each other just like this, and then you draw a line underneath it. Now, once you draw a line underneath it, now I'm gonna draw some lines here, and you don't necessarily have to put these in your notes because it kind of gunks up everything, but I'm just going to put them here and then I'll delete them. You want to think about it now that you're creating columns. You want an X column, you want a Y column, and then you want a C column or a whole number column. And when you put that line underneath there, you're going to evaluate each column separately. So I'm just going to look at my X's and I'm going to combine, or I'm going to, add and subtract my X's. So 2X plus 4X, because that's a positive 2 and a positive 4, is 6X. So I'm going to erase these columns now just because they kind of gunk up the place, but I wanted to show you what I'm thinking. So first you do your X's, right? 2X plus 4X is 6X. And the reason it's plus is because it's a positive 2 and a positive 4. Your minus 10y and plus 10y would go to what? Reduces to 0, right? So for now I'm going to put plus 0, but I'll show you here in a minute you don't really have to put that 0 there. And then negative 28 and positive 4 is negative 24. Now I'm going to clean this up a little bit and I'll show you. You can skip this line right here, because if you just write 6x and then this reduces to 0, you can do that. And then you can put equals negative 24, and you can skip the step of dropping that 0 out, okay, because it just kind of gets in the way. Now I'm going to divide by 6 and divide by 6, and I get x equals negative 4. Now that's half my answer, right? That's my x value. I still need a y value. So I'm going to go back up to either one of the two equations. It doesn't matter which one you pick. I'm personally going to pick the bottom one just because it doesn't have a bunch of negatives, and I like that, but it doesn't really matter which one you pick. So I'm going to go 4x, nope, not x, 4, negative 4, because now I know my x from right here, right? 4 times x, which is negative 4, plus 10y equals 4. And this is just like last week, right? Once you find one value, plug it in, find the other one. 4 times negative 4 is negative 16. And then we add 16 to both sides, because we want to move it off of there. And that gives us 10y equals 4 plus 16 is 20. Divide by 10, and we get y equals 2. That's the other half of our answer. So we plug it into our ordered pair, and then we circle it or square it because that's our answer. Okay, so you stack them on top of each other, and you get either your x or your y to eliminate. And then once it's gone, you can solve for the one that's left and then plug in to find the other one, okay? All right, so I'll give you a minute to write this example down, and then we'll talk through it. Yes. All right, so for number 2, the second example here, 2 equations, you good? 2 equations stacked up on top of each other. They're both in standard form, so we're set up right. So we're going to draw our line underneath it, and then we're going to look and see, does the x or the y eliminate? Well, in this case, you've got negative 3x, and negative 3x. Those don't cancel each other out, right? And then you've got negative 5y and negative 3y. Those definitely don't cancel each other out. But since the constant in front of the x is the same, if I force my bottom one to be a positive 3x, would my x's eliminate? They would, right? I'd have a negative 3x and a positive 3x. What could I multiply negative 3x by to make it positive? Negative 1. The rule in math, right, is if I do it to 1, I do it to all 3. So this is called manipulation, or kind of forcing something to eliminate. So I'm going to multiply that whole bottom equation by negative 1. By doing that, I don't change the value of it, because it's always fair in math. If I do one, I do all. So if I change this to a positive, this changes to a positive, and the 6 would turn to a negative. And I haven't broken any rules because I did it to all 3, so I haven't changed the value of the equation. But now it's set up to where I have negative 3x and positive 3x, and so my x's do cancel each other out. So that's good. I wanted that. I wanted one of them to go away. Now I look at my y's and I just reduce that. So negative 5y and positive 3y, negative 2y, and then negative 6 and negative 6. So two negatives goes deeper negative, so that'd be negative 12. And then divide by negative 2 on both sides, and I get y equals negative 12 divided by negative 2 is positive 6. So I've got my y value, which that's just half my answer. Now when I go back in here, I'm going to get rid of my x's just so they're not in the way. When I go back up to find my x, I can either plug into the top equation, the original bottom equation, or my manipulated bottom equation. It does not matter which one. I tend to usually pick the one I haven't changed just so I don't accidentally mess up a sign, but it doesn't matter which one you pick. So I'm going to take the top equation. Negative 3x minus 5 times y, and I now know y is 6, equals negative 6. That's that top equation with the y plugged in. Negative 5 times 6 is negative 30. Now I'm going to add 30 to both sides because I want to get all the whole numbers together on one side of the equation. I'm left with negative 3x over here. And I'm left with negative 6 plus 30 is positive 24. Signs don't match, so you subtract and take the sign of the bigger. And then I divide by negative 3 on both sides, and I get x equals negative 8. That's my x part of my equation, so negative 8 is the x value, and then there's my answer. And if I were to choose to plug that 6 into the bottom equation, I'd still get negative 8, okay? All right, any questions on the first two? On today's assignment, 15.1, it's either going to be it easily goes away and you don't have to do any manipulation, or you just have to multiply by a negative 1 on one of them to make something match up, okay? All right, so let's look at this one. Give you a minute to get it written down. Real quick while everybody's writing this down. Our three possible answers for system of equations is an ordered pair, right? An x and a y. What are the other two? Infinite and no solution. So it's the same with substitution, elimination, or graphing. You can get 1 point where they cross. You can get no solution because they're never going to cross. Or you can get infinite because they're actually the same line and they lay right on top of each other. All right. So looking at your x's here, you've got a negative 1 and a negative 1. They don't cancel out. Looking at your y's, you've got a positive 9 and a positive 9. They don't cancel out. So that means we're going to have to force one of them to change signs. So I'm going to take this bottom equation, multiply everything by a negative 1. When I do that, my x turns positive, my my 9y turns negative, and my 17 turns negative. Please remember to distribute that negative 1 to all three or else you get thrown off. All right, so now we have negative x and positive x. They cancel out or they go to 0. We have positive 9y and negative 9y. They cancel out. So what am I left with on the left-hand side? Not nothing, 0. Right? I'm left with 0 on the left side. Now, we tend to think nothing because we get in the habit of not writing that 0 there, and it's there even though we don't write it. So you just have to remember if there's nothing there, you got to put a 0 there. On the right-hand side, we've got 13 minus 14. What's that equal? Good, negative 4. Now, special case, because my x's and my y's both disappeared. Is this a true statement? So my answer is no solution. When both your x's and your y's completely go to 0 and you're left with no more variables, it's a special case. All right, let's look at this one. All right, we're going to draw our line, and we're going to kind of take a step back and look. Got negative 9x and positive 9x, so we're good there. They cancel out. And we got positive 5y and negative 5y. They cancel out, so what am I left with on the left? 0. And I got negative 25 plus 25. What's that equal? 0. Special case, because everything went away. My x's and my y's are gone. Since it's a true statement, it's infinite. Or you can write the word infinite if you prefer. My infinity signs usually are a kind of a hot mess, but that's okay. As long as I know that you kind of mean infinite, you're fine. Any question on those two? Those two are an example of when your x's and your y's both go to 0. One is a not true statement, one is a true statement. One is no solution, one is infinite. Yes, sir. On number 2? Oh, on number 3? Well, my original equations, let me take away these x's so you can see it. My original equation was negative x and negative x. They don't cancel out. And then my 9's, my 9y and 9y, you have to have opposite signs to cancel out. And so I didn't have opposite signs, so I had to force opposite signs. So I multiplied everything on the bottom by a negative. That made that go positive, that go negative, and this go negative. And then when I did that, not only did it make one go away, it made them both go away. So if your signs are not opposites, they won't cancel each other out. They have to be the opposite number. They have to be the same number but opposite signs. All right, let's look at one more example. All right, so we're going to draw our line here, and then we're going to kind of look at what we've got going on. So for our x's, we have negative 6x and positive 4x. They don't come close to canceling each other out. Our y's, we have one y and one y, but they're both plus, right? And we know that we need opposite signs to cancel out. So we're going to do a little forcing here, and we're going to do times negative 1 in this bottom one. And that's going to force all those bottom signs to change. So 4x becomes negative, y becomes negative, and the 10 becomes negative. Because the negative 1 gets distributed to all three terms. Now when we do it in columns, just look at your x's. You've got negative 6x and negative 4x, which is what? You're just looking at your x's. We've got negative 6x minus 4x. It's negative 10x. Our y's cancel out, so we don't need to put anything down there. We don't need to put the 0 down there because there's already something there. And then we've got 10 minus 10. What's 10 minus 10? 0. All right, is this a no solution? Do I stop here? No. Okay, that's kind of the knee-jerk reaction I usually get is people see that negative 10x equals 0 and they go, oh, that must be a no solution. My x isn't gone, okay? So I have to keep going. If my x didn't completely disappear, I have to keep working to get it by itself. Now I've got x equals 0 on top of anything is 0. So my x didn't go away. My x just equals 0, and that's okay. Keep going. And I'm going to plug into one of these equations to find my y. So I'm going to take that top equation, and I've got negative 6 times x, and now I know that x is 0. Negative 6x plus y equals 10. Well, 6 times 0 just goes away to 0, and I'm left with y equals 10. And so my y value, when my x is 0, my y is 10. And if I were to pull up Desmos and graph these two equations, they would cross at the point 0, 10. And I just want to real quick say something, okay? This is math laziness. because technically -6 times 0 is 0. There's no sense in writing it because the y is there anyway, and 0 plus y is just y. So it's kind of math laziness. And where that kind of gets you into trouble is examples like this, where both the x and the y go away, and people tend to leave it like this. So when x minus x is 0, -9y and positive 9y is 0, you have to have that 0 over there, okay? The only time you don't really have to write the 0 is like here. Because there was already a y over there, you didn't need a placeholder, so you could just not write the 0. So if not writing it and writing it sometimes and not sometimes messes with you, it's better to be in the habit of always writing it than never writing it, okay? All right, for those of you at home, make sure you've taken your notes in your 3-ring binder, and then click load and complete your assignment on Kami, and email me if you have any questions.